When we left off last time, we defined momentum, and we defined momentum as being like this capital letter P, that's just the letter that we use for it, equals and mass times velocity. So it's just, when we talked about conservation of momentum, this is just saying that motion is conserved. And I said it's not conserved when there is an exterior force. Otherwise, it is conserved. So if there is an exterior force acting on the system, then our momentum is not conserved. And what we can define from this then is this thing, if we look at, well, if I have an exterior force acting, that gives me some sort of change in my momentum. So let's think about what this looks like then. So a change in momentum would be, let's see, mass, it's going to be the same. We're not talking about adding to or taking away from. Mass times, let's see, final velocity minus initial velocity. And then I say, so an exterior force can cause that. So let's think about our units of force. So remember, we have force equals mass times acceleration. So I have what? Kilograms times meters per second squared. Oh, so I feel like I could write this as, let's see, what is this? This could be, I could go kilograms. Can I write this as meters per second times 1 over seconds? Can I write it like that? Then doesn't this look like a velocity? So let's rewrite that, and let's just be a little bit careful here, because it's not going to be a constant velocity, otherwise I wouldn't have acceleration. So this has to be some sort of change in velocity per time. I kind of feel like this looks like a momentum, mass times change in velocity. So this is a change in momentum per time is what we actually have for a force. So we can define our change in momentum in terms of impulse without a time, but I can relate that directly to a force if I have a time. So another way I can look at that is to say then impulse, equals, let's see, a change in momentum, or if I move the time up here, a force times some amount of time that force is happening. So not per time, but times time. Moving that over there. So that is my impulse. We can see that on a graph. We'll see that on a graph. So let's just do force and time on a graph. Just for ease, let's just do this. So we've done these graphs for velocity and acceleration and displacement, and we talked about things that we can get out of them. Sorry, dog. And one of those things that we can look at is the area under the curve. So if we want to look at this, what is that? That's going to be, let's see, this has units of newtons, and this has units of time. The area under the curve then is length times width, so newtons times seconds. So if I move this over here, if I have force times time, that has units of newtons times seconds. So this area under the curve, well, then that just gives me impulse. So if I plot force versus time, take the area under the curve, I can get the impulse. If I know my change in momentum, I can figure out what the impulse is. Or if I know the amount of time, then I can take my impulse, my change in momentum, and divide by time to figure out what my force was that caused that change in momentum. So this adds some really cool tools that we're going to go ahead and play with.